what I'm mainly doing is my main business is I'm running a small company called Qbotics Labs, and we are mainly into consulting, robotic software development. So, uh, like what IT companies does, right? They have some clients abroad, and they will outsource the project to India, and they will do that, right? So similarly, I have some clients abroad, and they will outsource some robotics related projects to me, and I will do that. Okay, me and my team. It's a small team. So this is the main business. I started my company in 2014. Before that, I was working in a robotic startup. Okay, and I'm also having a blog called Robocademy, mainly for like putting some tutorials, and I'm also conducting a ROS course, like 1 year course. So you can imagine how vast this subject is. Okay, and we are trying to see this topic in 2 days, within 2 days. So I mean, almost 3 hours, right? So we will be talking like very abstract manner. Okay, so yeah, and I had an opportunity to work in CMU Robotics Institute, which is very famous for robotics research. And I have taken my master's from India itself in robotics and automation, and I got an opportunity in speaking in TEDx as well. Okay, so this is about myself, and these are some of the books that I have written. Robot operating system for absolute beginners, then learning robotics using Python. So these are some of the popular books. ROS Robotics Project. I think while learning ROS, I think these books may help you. Okay. Yeah. So these are some of the books that I reviewed. There are some more books. I just put a few books here. Okay. Okay. So this is agenda for today's session. Okay. We have 1.5 hours. Okay. So we will be starting from the very basics. Okay. I hope yeah, maybe I can ask some questions after this. So we will be starting from like robot and robot programming, very basics. Then we will see what are the different robot programming approaches. Then we will start seeing ROS. Okay. So before starting the session, I just want to ask you a few questions. So if you uh, I mean, if you know that, maybe you can just raise the hand. Okay. So the first question is, how many of you already build a robot from scratch? Maybe it can be any robot like line follower or something. So how many of you made a robot before? Just want to know. So can you just raise the hand? I'm not sure. Are you sleeping, guys? Yeah, I think one. Yeah, Kevin. Yeah. So I think yeah, two now. Adil. Yes, I think out of 134, there is three people. Okay, build a robot. Okay, yeah, it's a count is actually increasing. Okay, five, only five. Okay, okay, fine. I think okay. So out of 135, five guys already created a robot, right? That's a small number. So I think it will be better to start from the very basics. Okay. Yeah. So maybe we can start from what is a robot and why robot programming. Okay. So I will quickly go through it. Okay. And if you have any questions, you can just pause. You can just unmute your microphone and ask. Okay. No issue. Okay. So these are very basic things. And maybe finally, so don't assume that this is the all session about. Okay, this is the basic, but at the end of the session we have a lot of demos coming, and I will be also explaining about the job opportunities, and I'm also showing some demos. Okay, simulation demos mainly regarding navigation of robot and all. Okay, so don't think that this is the session all about. Okay, so we are just starting it. So let me just present from this slide. Okay. So basically, if you already build a robot, you can able to see three different sections in the robot. Okay, so what are the main sections? I think you may have heard about this section before. Like a robot consists of three main parts, that is sense, including the sensors. Okay, then the think part. Think is it can be a microcontroller or it can be a computer. Okay, and the act is the actuators, right? It can consist of like motors, DC motors, or servo motors, stepper motors. Okay, so if you build a line follower robot before, you will get like the sense part is the color detection part, right? Whether the robot is lying on the line or is it out from the line. Okay, and that is a job of the sense part. It just sense. Okay, but the sense unit is connected to a computer or a computing unit, maybe a microcontroller or a digital circuit. And what is this digital circuit or the thing part does? Basically, it will take the decision. Okay, take the decision. Like the sense is detecting the like whether the line. It is detecting the some value. Like if the sensor is in the line, okay, then it will send some values to the thing. Then if the sense unit is outside the line, then it is sending a different value. Okay, so the think session, that is a computer, is actually processing it, and after processing, it is taking a decision, right? So after taking decision, it will send a control signals to the actuators, right? And what the actuator does is that it will move. Okay, it will move according to the command from the computer. Okay, the computer can be a microcontroller, a digital circuit, or a fully fledged computer, Raspberry Pi, anything, right? So these are the main building blocks of a robot. If you take a line follower robot, or if you take a complex robot like PR2, or any complex robot, you can find these sections. Okay, so I hope this is clear to you. Okay, and this is what happening inside a robot. Okay, the thing is that from the robot we are collecting the sensor data, and the computer is keep on processing the sensor data. Okay, and taking the and creating the control signals, okay, to move the robot, and the control signal is sent back to the physical robot. So the physical robot is having actuators, so it will move. Okay, simple, right? Yes. And this is one example for the robot loop. Basically, uh, this is an example of an obstacle avoidance robot. So in an obstacle avoidance robot, the objective is um, avoiding the obstacle or detecting the obstacle and stop. Okay, so imagine a robot is moving, and if there is an obstacle found, it has to move away from the obstacle. That's it. Okay, so here the sense part in the obstacle avoidance robot is maybe a obstacle detection sensor like ultrasonic sensor or IR sensor for detecting the obstacle. Obstacle means how much distance is the obstacle from the robot. Okay, so after getting the value, the sensor is connected to the think part, right? Maybe a microcontroller, and the microcontroller is taking the decision whether the object is very close or is it far from the robot. Okay, so if it is too close, then just move away from the robot, like just send the control signal to the motors to move away. Okay, so this is what happening in a robot. Okay, and I just do a block diagram of the robot. So let me take the pen. Okay, so here you can see the three blocks: think, act, and sense. Okay, and in the actuator, we will have a list of actuators, and sensor, there are different sensors. And in the think part, we can have maybe a microcontroller, computer, or a digital circuits. Okay, and these are some of the examples for sensors, actuators, and computers. I think you heard about the cameras. Okay, that is a vision sensor. Then ultrasonic sensor, which is basically for detecting the distance. I mean, how much distance is the obstacle from the robot with respect to the robot. And wheel encoders, which is basically for calculating the velocity of the rotation of the wheels. Okay, from the velocity calculation, we can find the displacement, how much distance is traversed. Okay, so wheel encoders. Then some of the examples of actuators are like servo motors, stepper motors, DC motors. I will show the images of these things. Okay, and computer, which is our main section. So in computer, we can have the PC, like there are many micro or mini PCs available. So the advantage is that we can easily put these computers on the robot. A robot will be like a small, I mean, it will not be a very big robot, right? I mean, there are big robots, but commonly what we are trying to do is like we will try to minimize the dimension of each component. Okay, so while choosing the components for robots, we will be choosing like mini computers. Okay, not the fully fledged desktop computer or something. So yes, so and there are many microcontrollers platform available. So popular, Arduino board, right? Arduino, then Launchpad, then STM32. So there are many. So these are some of the examples for the actuators. So you can see the servo motors, then stepper, DC gear motors, which are mainly using in mobile robots. Okay, and servo and stepper, like servo motors, like using in robotic arms, like hobby robotic arms. You can hear some disturbances from the background, sorry for that. Okay, yeah, and we have the industrial servo motor, which is using for industrial robots. You may have heard about it, the robot that is using for manufacturing cars and all. Okay, so these are the actuators that we are using for that. Okay, and we have some smart actuators available, which is like it's actually a module which is having the actuators and some control units. Then it's like an intelligent actuators. Okay, and these are some of the sensors. Um, these are some of the basic sensors. This is IR distance sensor. Then this is the ultrasonic distance sensor. And these are some of the advanced sensors. Like if you heard about the self-driving cars, you may have seen a sensor on the top, which is actually rotating. So this is actually the Velodyne LiDAR. So it can give you the 360-degree 3D view of the surrounding. Okay, so from the 3D, the 360-degree view of the environment, the car can able to detect the obstacles. Car can map the surrounding. It can do a lot of things. Okay, and we have the laser scanners, which is like which is giving the 3D points, okay, of the surrounding, but it may be only in a plane. Okay, there are some rotating laser scanners as well. And we have depth camera, which is very common in robots. I'm not sure you have heard about a sensor called Kinect from Xbox. So there, it's actually an old sensor, but there are many new sensors available. Depth cameras are like, it is having an RGB, normal RGB camera, and along with that, it is having a depth camera so that it can give you the 3D points, like XYZ points of the environment. Okay, so this is very useful while working with robots. Okay, and these are some of the computers that we are opting for small robots. Okay, you may have heard about the Raspberry Pi, which is very popular single board computer, SPC. Okay, because the word SPC means an entire computer is miniaturized and putting everything on a single board, right? It is having processor, RAM, GPU, then USB, Ethernet, Wi-Fi, Bluetooth, DisplayPort, everything. Okay, so currently, if you have a Raspberry Pi, You can even use it as a desktop computer. Okay, the new Raspberry Pi is very powerful. Okay, and even you can just buy this Raspberry Pi. I think the cost is around 2,000, 3,000 rupees, and you can just connect this board to a display and you can use it as a computer. Okay, and we have, if we want to work with some computationally intensive programs, then we have boards from NVIDIA Jetson Nano, TX2, okay, then Odroid. So these all are mini PCs, okay, single board computers. Then we have industrial PCs as well for industrial application. So I just want to show you some examples for the computing unit that we can use in robots. So there are single board computer, then these are mini PCs, Intel NUC, which is a very commonly using computer. Like it's actually work like a desktop computer, but in a miniaturized size. Okay, so Intel NUC is very popular. And yeah, so along with that, we are using microcontrollers for small robots. Okay, so we are selecting these components, like whether it is a sensor, whether it's actuators or computing units. We are selecting it based on the requirements. Okay, robot requirements. Yes. Okay, then we have seen a basic intro about robots. Okay, now we are switching into the robot programming. Okay, so simply, what is robot programming? You all know, right? Yeah, the thing is, we are just programming a robot to achieve something, achieve some, maybe some application, doing some application, right? So in my words, I will say the robot programming is basically modeling the behavior of the robot. Okay, and we are using some programming languages to program this behavior. Okay, and we are taking the input as a sensor data. Okay, you have seen a lot of sensors, right? So we will be taking that sensor data as input, and this programming language will process it. Okay, and send a control signal to the actuators. Okay, so output of this model is the robot actuators. Okay, so input is sensor, then the model will do all the processing, and it will send the control signal to the actuators. Okay, so we are basically programming the or modeling the behavior. Okay, we are creating a model basically, and so that is robot programming, and we can use any programming language to program a robot. Okay, so if you are very familiar with Arduino or something, Arduino board, you may be working with simple robots like line follower or something. Okay, so in that we are using a C++ kind of language. Okay, it's called wiring. And we can use any programming language, C++, Python, or you may be using MATLAB. So any programming language you can use. Okay, so commonly we are using C++ and Python. Okay, that is the more popular programming languages for robots. Okay, yeah. So these are the two approaches to program a robot. Okay, again, very simple concept. Like either if you are planning to do a project, first, like we have two options. First, you can just go to Google and search about some existing projects. Okay, very similar to your project, and you can just customize it. Okay, that is one approach. So this may be the approach that almost all the people are doing. Okay, but the next approach is writing everything from scratch. Okay, so if you want to do something, you have to write everything from scratch. Okay, so if you want to program a robot from the existing software framework, then there are many examples for that. Arduino framework, okay, which is an existing framework to program microcontrollers and thereby robots. Okay, and we have a software framework called Robot Operating System. Okay, which is again a high-level programming language. High-level software framework for programming robots. Okay, so these all are some existing stuff. Okay, so that we can take it and we can use for programming the robots. Okay, otherwise you can simply use some programming language like C++, Python, and you can start writing the programs for the robots. Okay, So the first thing in the first approach, it will be very quick. Like there is an existing framework available, and we can use it for quick prototyping. Okay, and so if we are planning for uh, working for a product, then it needs a lot of fine tuning. Okay, so that is one problem with the working with existing software framework. Okay, and if you are working from scratch, then the problem is it will take a lot of time, but it will be better in the long run. Okay, and yeah, so these are the two approaches that we can opt to program a robot. Very simple concept. Okay, and these are some of the existing software frameworks available. Robot operating system is one of the software framework available to program robots. And I'm not sure how many of you heard about the OpenCV, open source computer vision. How many of you heard about OpenCV? You can just raise a hand. Anyone? Anyone heard about OpenCV? Okay, okay, yes. I think 2, 3. Yeah, I think a lot of people. Yes. So OpenCV is actually a software library, which is for doing computer vision application. Okay. So it's again a existing software framework to program robots. Okay. And there is PCL, Point Cloud Library, which is for processing the point cloud data. So I have shown you a LiDAR, right? Velodyne LiDAR. So which is basically giving the 3D point cloud. Okay, point cloud is a 3D data. Okay, it's not like image. Image is a 2D data, right? Point cloud is a 3D data, and using the point cloud library, we can able to process this 3D data, and after processing it, we can do 3D object detection, then collision avoidance, a lot of things. Okay, in 3D domain. Okay, yes, these are some of the software framework. I will explain it later. Yeah, maybe this will be useful. So if you are planning to create some simulation, robot simulation, then the first simulator, maybe the Gazebo, is an open source robot simulator. That is, we will get this when you install ROS. Okay, and this is another two simulators like WebBoards and VREP. Okay, these are very good simulators available. Both are free. Okay, VRUP is actually, there is a free version available and there is a proprietary versions available as well. Okay, yes, and these are the popular programming languages that we are using, like C++, Python, Java for programming robots. Okay, okay, so let me switch to another topic. So after that, we can start with ROS. Okay, so I just want to. So this is not a very, I mean, mandatory, but I just want to say. So imagine you are creating a line follow robot. Okay, so in that, you may not need a full-fledged computer. Okay, you can use maybe a microcontroller. Okay, and you can use maybe a digital circuits, right? Because why? Because the computation required for doing line follower is very less. Okay, and but just consider these robots. Okay, so in these robots you can able to see there are two robotic arm, then there are different sensors, then a mobile based. So there are a lot of features that are, yeah. So do you have any questions? Okay, okay, I think someone's mic is not mute. Okay, fine. So if you want to work with this kind of robots, then you may have to use a full-fledged computer, right? So in case of line follower, we can use a microcontroller, but in case of complex robot like this, we may need a full-fledged computer. So if there is a computer, we may need an operating system, right? So what are the operating system that we are using? Like Windows is there, then Ubuntu is there, right? So in case of complex robot, we may have to use an operating system, okay? Operating, and we have to use a full-fledged computer as well, okay? But in case of small robots like this, we may not need that. Okay, so that's what it is saying. And um, the most popular operating system that we are using in robots are like Ubuntu or Linux variant. Okay, Linux variant, and we are also using Windows. Okay, Windows. And if you want to work with some real-time operating system, real-time task, then QNX and VxWorks are there. Okay, so you may have some confusion, like the robot operating system ROS is whether it's an fully fledged operating system or not. Okay, so I will answer that question. It's not a fully fledged operating system like Ubuntu or Windows. It's actually called a meta operating system. Oh, I will come back to that. Okay, so just understand that we may need a full-fledged computer to process the sensor data from the complex robot. Okay, but in small robot we don't need that. Okay, that's a differentiation. And so in complex robot like this, we may need to install some frameworks like ROS, OpenCV in order to process the data from the sensor, like the vision sensors, then LiDARs. So in order to work with these complex sensors, we need to install some libraries on the top of this operating system. Okay. Okay, so let's start with ROS. So before starting with that, I just want to mention, like, if you want to learn this framework, you have to learn these two things. Like, mainly, you should have an understanding about Linux commands. Okay, Ubuntu, mainly Ubuntu, working with Ubuntu, and understanding of Linux commands. So I can show you that. So this is Ubuntu 20.04, and you should have some understanding in working with these Linux commands. Okay, so these all are called Linux commands, bash commands. And before starting working with ROS, I think you should have some understanding in working with shell. Okay, so this is the one of the mandatory requirement if you are starting with ROS. Okay, and next is programming know-how. Okay, either C++ or Python. Okay, you should need, because uh, we are actually going to program robots using the ROS framework. Okay, so to program, we need some understanding on some programming languages, that is C++ and Python. Okay, so C++ is the popular programming language, and it is fully supported all the functionalities of ROS. But Python, uh, I will say like 90% of support. Okay, but if you want to explore all the possibilities of ROS, I will say C++. Okay, so Linux commands know-how and C++ is a must, and optional requirements are like Git. Okay, a knowledge in Git. Git is actually a version control system. I'm sure that you heard about the GitHub, right? So GitHub is actually a cloud solution for storing Git repositories. Okay, so this is one of my Git account, and there are different Git repositories. So you also have to know how Git works, and how to push the code to GitHub, those kind of stuff. Okay. Yes. So these are the prerequisites. Okay. Uh, I hope some of you have this, but if you don't have, then you can develop it and start working with ROS. Okay, but don't worry, you can attend the session, and you will understand what is happening. But when you start doing something, then you require this stuff. Okay, yes. So I'm starting with ROS. So I can't directly jump into ROS because not everyone are aware of all this stuff. So that's why I started from the very beginning. So what is ROS? So maybe I can explain without using slides. Um, so ROS is simply a software framework. Okay, so what is a software framework? Software framework is actually a group of programs, maybe. Okay, group of programs, and that is actually designed to do some purpose. Okay, some purpose. So So why we need this? Why we need these kind of software framework? Okay, so if you don't have the software framework, so in order to accomplish this purpose, we need to write everything from scratch. Okay, so ROS is giving some powers to us. Okay, some powers. So if you're not using ROS, that's fine. Okay, but we have to write it from scratch. Okay, we have to write it from the very beginning. Okay, so you can either use this framework or you can write everything from scratch. Okay, so what is the power that ROS gives to us? That is the next question. So in order to understand that, I just want to go to an intermediate slide here. Okay, so if you have any questions after explaining this, you can directly ask, because this is one of the important concept in this session. Okay, an important concept in ROS as well. Okay, so I'm not sure everyone is familiar with these terms. Okay, but you can ask. I will give you time after explaining this slide. So after correcting everything, we can proceed to the further slides. Okay, next slide. Okay. Okay, so which all are the programming languages that you have used to program? Like, how many of you use C++ before, like to program? C++ programming language. How many of you? Just raise your hands. Okay, one. So I'm expecting like more than 50 minimum. Okay, there are 152 students. Okay, 21, 24. Yeah, 20. Yeah, good. Yeah. 33. It's 40. Okay, okay, 40. Okay, fine. 40 is fine. Okay, so I think I'm assuming that most of you have done programming using C++, right? So uh, on the top of Ubuntu, we are installing ROS. Okay, just imagine we have the ROS and we can write programs using ROS. Okay, so don't worry about the ROS and all, but just imagine we have several programs here, like program 1, program 2, program 3, program 5. Okay, so these programs, okay, these are different programs. Okay, and these are running in parallelly. Parallelly means you are running program 1 first, okay, then program 2 first, and program 3, program 4, program 6. Okay, so these programs are running like simultaneously, but these are different programs. Okay, and while these programs are running, if one program like program 1 want to send some data to program 2, imagine. Okay, so how can we send a data from program 1 to program 2? Anyone try this kind of communication between two programs before? Anyone? Like you are running two programs, okay, and one program is just sending some data to another program, okay, and another program may be sending some data to another the program 1. Okay, so anyone try this kind of programming? I'm not sure you have done it, but I'm just asking, like communication between two programs. Okay, anyone try this kind of programming? Maybe you can unmute your microphone and say, like, anyone tried communication between two programs before in C++? I think some of you are trying to unmute but not talking. Anyone tried this kind of programming, guys? Like two programs or multiple programs are communicating with each other. That's it. Communicating means like sending some data. Anyone try?
Yes, sir.
Yeah. So, Tamim, yeah,
Uh,
you can. How did you
Sir,
do
it's
that? Like,
I think a few of you have already tried this. Uh, so just like Sending
Yeah.
some Bluetooth signals or Bluetooth commands from your Arduino boards to mobile phone or like that. Is that?
Okay, okay. So yeah, so that is a different one, but yeah, the
Yeah.
thing is here, the context is we are running the programs in our computer. Okay,
Yeah. Okay.
in our computer, and these two programs are running in our operating system, and these are communicating with each other like that. Okay, so what you are mentioning was like you have some apps in your Android phone, and the Arduino is communicating to the Android app through Bluetooth. Okay, that is actually communication, but here the context is the programs are communicating with each other. Okay, so that is the context. So I think none of you have tried this kind of programming, right? I'm
Sorry,
assuming.
just
Yeah, tell me.
just just simple API communication. Is that correct? Like
Yeah,
a front end
API.
or back end. It's
Yeah,
running on.
that is also correct. Yeah, so you are communicating from the front end to the back end, right?
Yeah.
Yeah, that is again a communication. That's a communication, right? Yes. So what Tami mentioned was he's having a front end like a graphics interface, and he's sending some commands from the front end to the back end. Back end may be a database or something. Okay. So the front end is sending some commands to the back end. Okay. So what is happening is that there is a data transfer happening. Okay. Uh, inside the operating system. Okay. And why is it necessary? Like why we have to send data from one program to another? So you may be thinking like in the context of robotics, why we need this, right? You may be thinking, you may have some confusion. So I will explain it. So in case of small robot, I mentioned that you may need maybe a microcontroller, okay, uh, to write the entire program of the robot. Okay, maybe for doing the line follower. But in case of a complex robot, like the robot is having many sensors, actuators, and it is doing a lot of functionalities, it is doing a lot of applications. In that case, we have to put a full-fledged computer on that robot, right? Maybe not only one computer, we may have to put multiple computers in order to process the sensor data, right? Yes. And on this computer, we have to install some operating system, right? This is actually full-fledged computer like laptop that we are using. So we have to install an operating system. Say it's an Ubuntu operating system. Okay. And we have to do all the sensor data processing, right? For example, in a complex robot, we have maybe sensors like camera, LiDAR, laser scanner, touch sensor, wheel odometry, wheel encoders, then obstacle detection like ultrasonic, then like that, there are many sensors are available. Okay. And there may be 10 or 20 actuators also available. Okay, 10 or 20 actuators. So can anyone say how can we write a program, okay, for this robot, this kind of complex robot, in order to process the sensor data and in order to send the control signal to the actuator? How can we program? Your challenge is write a C++ program, okay, write C++ program in order to process the sensor data and control the robot. Okay, so can anyone say an approach to write uh, a code for controlling this robot? In case of line follower robot, we can do everything in Arduino board, right? Arduino IDE. But in case of complex robot, like which is having many sensors and many actuators, and it is doing a lot of jobs, okay, different application. How can we write program for this kind of robots? Can anyone say? It can take some time. It can take some time. Like um, how to program a complex robot. I mean, what I'm intending is the approach. How can we program? Can we program in a single program or a multiple program? Can we program everything in a single program, guys? Any idea? Anyone? Like, even if you're wrong, that doesn't matter, because if you're saying something, that means you are participating in the discussion. And like most of the presentation will be like lecturing, but I'm not very interested in it, because if I can involve you in the discussion, I think that will be better. So that's why I'm asking, like, which will be better to program a complex robot? Will it be a single program or a multiple program? Which approach will be better?
Multiple.
Multiple? Yeah, tell me. I'm not sure. I think.
Hello, sir. Hello, sir. Am I audible?
Yeah. Yes. Yes.
Yeah, I think the best approach is writing multiple programs or multiple functions.
Okay. So can you just differentiate why the single programming? I mean, single program approach is not suitable for working with a complex robot. Like, imagine.
I'm not.
Yeah. Yeah.
It's suitable, but the best method is writing multiple programs because we can reuse the programs and we can understand each functions or each lines.
Yeah.
Just like if we are taking an input from the robots, from a sensor or camera, then we can write a program for that that sensor, particularly that for that sensor. And
Yes.
if later we can make the changes very easily.
Yes.
If we are doing that program in a single file, or not a single file, in a single program, the modification is very difficult.
Exactly. So what Tamim said was correct. So the thing is that if we have many sensors and many actuators, if you are writing a single program for handling all these sensors and actuators, the code length, okay, the code length of the program, the single program will be very, very high, okay, and at the same time, it's very difficult to debug. Okay, it is very difficult to find issues in our code. Okay, and at the same time, like, we are handling with many sensors, and many sensors are communicating in different rates. Okay, so it's very difficult to write a single program to handle everything. Okay, so the next approach is we can write different programs for handling different sensors and actuators. Okay, so we are just making individual programs that is handling for which is doing some specific work. Okay, and all these programs are communicating with each other. Okay, and it is I mean, it's like a, I mean, you can able to see, like, right, these all are independent programs. Okay, and all these programs are doing one task. Okay, one or two tasks. Okay, not more than that. And after processing it, it is communicating, it is sending some data to another. Okay, and it is accomplishing a task. Okay, so this group of programs are doing some jobs, okay, individually. Okay, not I mean, all these programs are working as a team and doing the task. Okay, it's not one program is doing all the tasks. That is the difference. Okay, so why we are discussing this thing in the robotics context? Because if you are planning to work with a complex robot, we need to write different programs for accomplishing this kind of complex task. Okay, so here the program one may be doing some task. Okay, and after processing it, after doing the processing, it is sending some data to another program. Okay, and another program may be doing some other processing, and it is after processing it may be sending the data to another program. Okay, so like this, for doing a task, we are creating a structure like this. So can anyone say what is this structure? What is this structure? We have many programs, and these programs are connecting with each other. So anyone say what is this structure? The name of this structure?
Graph.
Yes, yes. Okay, so it's basically we are forming a graph. So I have mentioned it's a title, but it's actually a graph, right? Graph of programs. Okay, so I'm using the word programs, but that is not exactly correct. So if you are creating a program, means you are writing the code. Okay, you are just writing the code, and if you compile it, and if you create the executable, and if you run it, okay, if you run it, then we are calling it as a process. Okay, so the running entity, like the running instance of a program, is called the process. Okay, so all these nodes are actually process. Actually, these all programs are running. Okay, and while running, it is processing the sensor data or doing some jobs, and it is communicating with each other. So basically, it is forming a graph of process. Okay, in ROS, we are calling the processes nodes. Okay, in graph also we are calling nodes, right? Nodes. So here we are forming a graph of nodes, okay, which is able to do some task, okay, by sending and receiving data. Okay, so the core part of ROS is how these programs are communicating with each other. Can our normal C++ program can able to do this, like sending data to another program or receiving data? Can our C++ program, like if you do a regular C++ program, if you write, can you able to send a data to another program? No, right? There are options, but in our normal programming, there are some difficulty to achieve the communication between different programs. Okay, so what ROS does is that ROS is a software framework, and it is giving us some functions. Okay, some functions, and we can use this function in order to communicate with another program. Okay, so if you are using ROS inside your programs, okay, ROS API we are calling as a API or functions. Okay, and if you use ROS API in your program, you can able to communicate with another program. Okay, for example, program one is reading the sensor like camera. Okay, and program one is doing some processing and sending some data to program two. Okay, and program two is receiving it. Okay, so this kind of communication can be established using ROS. This is a core part of ROS. Okay, so the context is, if you are working with a complex robot, you may need to write different programs to accomplish a task. Okay, so in order to write multiple programs and in order to accomplish this task, these multiple nodes have to communicate with each other. Okay, the communication is basically for sending or receiving some data, some kind of data. Okay, so this communication can be established using the ROS framework. Okay, so this is the heart, I will say the heart of ROS. Okay, using ROS, we can able to create programs that can able to communicate with each other. Okay, and when these nodes are communicating with each other, it's basically forming a graph of nodes, graph of nodes. Okay, so this is what we call the ROS computation graph. Okay, ROS computation graph. So let me know if you have any questions related to the computation graph. Okay, after that we can proceed to the next section. Okay, so it's raining outside, so if you have difficulty in hearing, maybe I can mute my microphone for a while and you can ask questions if you have any confusion. Okay, so just involve in this discussion because then only it will be useful to you. Okay, if I'm simply lecturing, it may not be useful. You can ask your doubts. Okay, maybe we can take 5 or 10 minutes maximum for this. Okay, if you have any doubts, let me know. Any question, guys? I'm not sure. So is it clear, guys, or is it confusing? I just want to know that. Tamim, did you get this point? How this communication happening?
Yeah, yes, sir.
Okay, I think one guy got it. Okay, what about others? Yeah, I'm not sure. Like, okay, so I'm assuming that I think Tamim, your mic is not mute. Yeah, thanks. So I'm assuming that you got this idea. Like, just understand the context. Like, while working with complex robot, we may have to write different programs for doing different functions. So while writing different functions, different programs, uh, these programs or these process has to communicate with each other. So ROS actually gives us some functions or APIs, okay, that can be used in our programs, okay, and we can use that APIs to send or receive data, okay. So program one is doing like reading from one sensor, and that value is sending to program two. Program two may be processing it, and program two sending the process data to program five, and program five may be sending data to the actuators. Okay, then the program five is moving the robot. Okay, so like that we are dividing the entire programming. We are just splitting the task and we are just giving into multiple programs. Okay, and all programs are doing each part of the job. Okay, and it's communicating with each other. Okay, so for example, if you have some assignments and all, like a group assignment, what everyone does is that or it may not be a group assignment. If it is a group project, maybe um, each and everyone is doing different task, right? And after that everyone will communicate with each other and we will have final results, right? But in reality it's not. It's actually might be like, from my experience, like if 5 people are in a group, maybe one guy is doing everything. Right? Yeah, but in ROS case, if there is 5 program, they are doing like different tasks, and finally it will accomplish the complete task. Okay, so this is a important concept. Okay, it's called the computation graph. Okay, yes. So let me switch into the previous slide. So we have seen the importance of ROS, why it is using. So now I just want to show you my project that I have done in my bachelor's. It's called a social robot. And so this robot was not programmed using ROS. Okay. And you can able to see there are different sensors. We can say it is a complex robot because there are many sensors. Like these are 2 cameras and there are 12 actuators and there are many capabilities. So we can't write everything in a single program. We have to write different programs to accomplish this task. Okay, so at that time, so these are some of the capabilities. Like it can interact with people using natural languages, using there are some simple pattern matching techniques available. so it will work like Siri. Okay, so this was happened in this project was happened in 2010. So at that time, Google Assistant that was not very available. I have used the speech recognition from Microsoft. Those kind of tools I have used, and like face detection, motion detection, object detection, those kind of stuff were there. And mainly the programming languages were Python and C++. Okay, and so obviously I may need multiple programs, right? So what I have used was I have used server client architecture. Okay, so I think Tamim was mentioning like front end and back end, right? Front end and back end. So that front end and back end can be achieved using this client server. Okay, client server is kind of communication. Okay, so server can communicate to client, maybe client can communicate to server. So I just created a server client architecture in order to do the communication. Okay, so we have computer vision, speech processing, artificial intelligence, Arduino communication. So these all things are doing by different programs. Okay, so I created a communication system like this to able to communicate everything, every program. Okay, but it's very difficult to implement from scratch. Okay, so after that project, this was one project that I have done using ROS. Okay, so using ROS, everything was very easy. The main objective of this project was implementing navigation, autonomous navigation, meaning imagine the robot is in position A, and if I'm giving a goal position called B, it will go to B by avoiding obstacles and everything. Okay, automatically. Okay, so this was using ROS, and I could able to create the computational graph. Okay, so this is the computation graph. You can see like these are each nodes. Okay, so you can able I can able to create nodes for navigation and also the communication very easily using ROS. Okay, so what I'm trying to say is ROS is one framework mainly using for complex robots. Okay, in order to write programs which can able to communicate with each other, okay, and exchange data, okay, and create a computational graph. Okay, so this is the heart of ROS. Okay, yes. So let me switch into the installation of ROS. Okay, and some basic explanation of the ROS as well. So let me switch to the slide, and if you can open your browser. Okay, just open your browser and just enter ros.org. Okay, ros.org. I'm not sure how can I put comments here. Okay, I think it's disabled, I guess. No problem. Like ros.org, you can just take. Okay, so this is the official website of ROS. Okay. Okay, so I just want to explain in specific what is ROS is. ROS is a robot software framework, okay, and it's open source, meaning the code is open. You can able to see the code, you can able to customize it, okay, and also it's open source and also it's free. There is no cost associated with it, okay, so free for use, open source, and it's a software framework for programming robots, especially complex robots, okay, and it's not a real operating system. Okay, it's not a real operating system. It's actually called a meta operating system. Okay, meta operating system means it is having some features of operating system, some features, okay, like message passing, communication, then yeah, so those kind of features, but it needs a host operating system to run. Host operating system in our case is Ubuntu, Windows, Mac. Okay, so those are host operating system. So in short, the ROS is not a real operating system. It's a meta operating system. Yeah, and it needs a host operating system to run. Okay, and we have seen the website. Okay, so the website is one of the key resource to learn ROS. everything, all the tutorials and installation, everything is there. Okay, but it will take some time to get started with the website and the tutorials. Okay, so it will take some time. So I will guide you how to quickly go through it. Okay, so the first step, like I mentioned, that's an software framework, right? And it can be installed on Ubuntu. Okay, let me take. So if you have in this website, just go to getting started and take install. And in that, you can able to see ROS Noitic Ninjamis, okay, then ROS Melodic, ROS Foxy, okay. So the ROS we can install on your Ubuntu operating system or Windows. Okay, the complete support, the full support is currently on Ubuntu. Okay, you can install it on Windows, but I think there are a lot of bugs, and there are I mean, the compatibility is not complete. I mean, there are still a lot of things to port into the Windows framework, Windows operating system. So the complete features is available on Ubuntu Linux. Okay, and there are two versions of ROS, ROS 1 and ROS 2. Okay, so the ROS 1 is actually started in 2008. Okay, 2008 literally, and now it's 2021, right? So you can imagine the legacy of ROS 1. It's like 12, 13 years, right? Okay. And ROS 2 is actually started in 2016-17 time. Okay, it just started. So the difference is that the ROS 1 basically designed for research purpose. Okay, research purpose. And but the problem was like it started in 2008, right? So after a few years, the companies are started taking this framework for their product. Okay, so when we are using ROS 1 for a product, there are a lot of issues. Issues in the sense, basically, it's not designed for a product. Okay, that is the first issue. Okay, and why? Because there are a lot of issues with the security aspect. Okay, security, then what? Like stability. Like if you have to put a software on a product, okay, it should be stable, right? So in order to test the stability, there are different testing methods. Okay, so ROS is not it's not passed those testing for a product. Okay, so in order to make ROS 1 as a product, in order to include ROS 1 in a product, we have to do a lot of other stuff. Okay, we have to enhance the security, we have to add like stability code, lot of testing. Okay, so the ROS 2 is the new version. Okay, so which is like handling all these things, the security aspect, then stability, and it is designed for a product as well. Okay, research and product. Okay, but ROS 2 is still having some bugs. Okay, some bugs because it's only started in 2018, right? So only like 3 years. But ROS 1 started in 2008. Okay, so it's ROS 1 is very stable. ROS 2, I will say it's not very stable compared to the ROS 1. Okay, so in this session, we will be discussing more on the ROS 1. Okay, so the latest version of ROS 1 is ROS Noitic. Okay, this is the last version of ROS 1 as well. Okay, we will get support up to 2025. So in order to install ROS 1, we need Ubuntu 20.04. 20.04. So you can just take Ubuntu, Chrome and like Ubuntu 20.04. So you will get the image, disk image of Ubuntu 20.04. Then you can burn it to a USB and you can install it on your real system. Okay. or you can use software like VirtualBox or VMware. Maybe I can just show you that VirtualBox. Okay. So this is a software for doing virtualization, meaning by standing from Windows, I can work with Ubuntu. Okay, here I am in Windows, but I can work with Ubuntu as well. Okay, so VirtualBox or VMware. Okay, just a second. These are two popular options that you can work with Ubuntu and also Windows in parallelly. Okay, but if you want to work with Ubuntu alone, you can install Ubuntu on your real system. Okay, so this is a good solution for doing the virtualization to install Ubuntu. Okay, after installing Ubuntu, you can install ROS on it. Okay, so there are a lot of tutorials available to install Ubuntu on your system and also VirtualBox. Okay, in YouTube. So in order to install Noitic, just press the install button, and this is the installation instructions. Okay, so I mentioned that we need 20.04, right? So in order to install, you can simply copy paste these comments. Okay, copy paste these commands to the Ubuntu terminal. Okay, so you can just go through this instruction and just go through this step and install the desktop full. I hope some of you have already set up ROS Noitic in your system. So let me know how many of you already install ROS on your system. How many of you? Yeah. Okay. Okay. So I think a lot of students are already installed. Yes. Good. Yes. So if you have any confusion in the installation steps, let me know. Maybe you can ask if you have any doubts in the installation. Okay, so if that installation is correct, if everything works good, then what you can do is, in order to test, you can type this command. If you have a Ubuntu system in front, or if you have a VirtualBox, just start it and just execute ROS core command. Okay, so if that command gives this output, then it means your installation is proper. Okay, so you can test it. Okay, so if you are in front of a Ubuntu system, you can do it now, and if you are getting any error, let me know. Maybe we can fix it now itself. Maybe you have some error, like if you are not setting up this code, these two commands, you may have errors. Okay, so make sure the ROS core command is working. Okay, yes. So this is the installation step. Okay, and after that we can test it using ROS core. Okay, yes, I think from now from the ROS equation, I think we can discuss in the next section, that is tomorrow. So I'm just concluding for now, like up to the installation, make sure everything is proper. If you have any errors, or if you have any confusion in the installation, you can ask me in the next session or now itself. Okay, after making the installation correct, we can start working with the ROS. Okay, start working with the ROS. There are a lot of things to discuss. Maybe tomorrow I can show you that. Okay, yes. So let me know if you have any questions so far regarding the installation or regarding the computational graph. If you have any question, let me know. Or any other questions if you have, then let me know. And after fixing that, we can just conclude today's session. Any question, guys? Okay, I think this is clear to you. Till now, what we have discussed was okay for you. Okay, so from tomorrow we will be starting with the ROS equation. Okay, ROS equation, and we are planning to start some hands-on session as well. Okay, and probably we can see some basics using ROS turtle sim. Okay, and if we get time, then we can also plan for some programming. Okay, it's very difficult to do the programming online because if you have error, then it's very difficult to debug. Okay, there are many people online, right? So it's very difficult to debug, but we can try. Okay, or I can show some demos as well. Yeah. So if you have any question, let me know. Yes.
Sir, Ashwin Abraham has put some doubts in the chat session. He's getting some error.
Okay, so I'm not able to see the chat actually.
Sorry, sir. I think it's disabled for guest.
Yes, yes.
Yeah.
Yeah,
It's
so maybe you can.
the error is showing ROS score not found.
Okay, yeah. So if you have that error, that means I can show you that. So probably you will install ROS up to this step. Okay, up to this step you may have done, but after that, so if you complete this command, that means you have installed ROS. Okay, you have installed ROS. So when you install ROS, we will get a lot of tools, command line tools, then yeah, a lot of tools you will get. Okay, so in order to access these commands, what you have to do is you have to set up the environment. So there is another step here. So from 1.4, you only have to do this. Okay, desktop put. So in 1.5, we have the environment setup. Okay, so in that you can just copy paste these two commands. Okay, first copy paste this command, and after that do this, then execute ROS code. Okay, so the meaning of this command is basically we are adding a command called source /opt ROS noetic setup dot bash to dot bash rc file. Okay, so I will show you that. So in the home folder there is a file called dot bash rc. Okay, so which is a configuration file for the terminal. Okay, so this dot bash rc file will be executed whenever we open a new terminal. Okay, so you have to open either open .bash rc, or you can directly, if you have any confusion in that, you can simply copy paste these two commands. Okay, these two commands and then execute ROS code. Okay, so if anyone getting ROS code not found, you can do this. Okay, two lines. Let me know if that is working. And after that, you can also install these command as well, this one and this one. Okay, so don't stop here. Okay, there are further steps here, so just do this, then after this, then this and this. Okay, so then it will work smoothly. Okay, so any more confusion, guys? So today we can take time to solve the installation. Okay, so once the installation is correct, then you can start working on ROS. Any more errors, guys?
Sir, some more. Either can you please unmute the mic and say the error?
Hello.
Yeah, that will. Yeah, tell me.
So on doing that, I'm getting like it shows that no such file or directory exists.
Okay.
I'm getting a message like that.
Okay. So that means, did you able to do this step successfully?
Yes, I was able to do that, but not the other remaining
But
steps.
I mean, only this you have to install. I mean, you have to execute this, and after that, if it is everything successfully finished, then you will not get any error. If Make sure you are not getting error after completing this step, then you have to do this. Okay. Then after this, if you can take a new terminal, okay, maybe you can take a new terminal and check the raw score again.
Okay, sir.
I think if this path is not found, that means the installation is not proper. So maybe you can try. You can try. You can simply copy paste. That is enough, I guess. Okay. Yeah. Yes. If this is not found, that means installation is not proper. That is the assumption. So just try this command. Just copy paste this command again to the terminal and just try whether it is giving this message. Just a second. If everything is finished properly, you will get this message. Setting up ROS desktop full installation. Then yeah, if we are getting this message, that means all the installation is proper, because um, this command, it will take approximately like 20 to 30 minutes to complete. Okay, basically it is pulling a lot of packages and installing, so it will depend on your internet connection and your computer performance. Okay, so yeah. Okay, so if you have error further, maybe you can either send to Tamim and he will send to me. Okay, so I will check that maybe in WhatsApp or something. Yeah. Yeah. So any more error? Yeah, Tamim. Yeah.
Sir, Adil, Adil, you have some doubts, right? Please ask.
Sudo apt update.
Yeah. Yeah. This is needed. This is needed.
So I can't execute that. It's showing that unable to lock directory.
Unable to.
Unable to lock directory.
Okay. So yeah, understood. Yeah. So you're seeing a lock, right? Is it lock?
I don't know about that.
I mean, can you just say that unable to lock the directory, right?
Yes, I have shared the email screenshot to Tamim.
Okay. Okay. Yeah. So yeah, I will check that. Mostly, this can happen if you do sudo update, and if we take, for example, maybe I'm just trying to reproduce the same error. Let me try.
Sir, I think he may try to install two software at a time.
Yeah, maybe that as well. Like if we have like if you are trying to install two things at the same time, installing two things at the same time, it will show error. So I was trying to replicate that. So the lock may be because of that. Okay, so if you do the sudo update here and update here, oh sorry. So if you execute both at the same time, let me. Yeah, so you may get like could not get locked. This kind of error maybe you will get. Maybe you can just send to Tamim and yeah, I will look that. Okay. Yes. So like while setting rows, you may get different errors, but Mostly it may be because you're not following that the step properly. Okay, I can explain um, some issues like if um, if you're working with some proxy server or something, this command may not work. So you have to do this command. Okay, and if you have difficulty in following this installation step, then I can give you a one-line installation that will be more easy for you. So I have created a one-line installation for ROS Noitic. Just a second. So you can just go to Google and just search about ROS Noitic one-line installation. So one line means you can simply copy paste one line for installation and again one line for uninstall. Okay, so this is one post that I have created and there is a video as well. So in order to install, you can just copy paste this line to the terminal. Okay, so installation and everything will work. Okay, so just maybe I can send these links to Tamim as well. Okay, so that you can use it for installation and uninstall the same. Okay, so you will get this script from the GitHub. So this is the script. Actually, I have put everything, all the things in a single shell script. So it will be very easy to install Noitic in a single command. Okay, so you can also try that if you have any difficulty. Okay, yes. So I think we can conclude, and if you have any issues getting, you can WhatsApp to Tamim and he will send to me. Okay, so I will check. So before the next class, make sure the installation is proper. Okay, then from tomorrow we can start with the ROS stuff. Okay, tomorrow the same time. Yes. Okay, so Tamim, I think we can conclude today's session.
Yes, sir. Thank you, sir. Thank you for your time. And
okay.
Yes,
yeah,
thank you,
tomorrow.
Sir.
Yeah, tomorrow at the same time, like 11 o'clock. And just prepare with your ROS installation. Okay, and yeah, as I mentioned, like you can send errors to Tamim if you have any, and we will try to fix that first in the next session. And after that, like we will start with ROS concepts, examples, simulation, those kind of stuff. Okay. Yes. So thanks, guys. Thanks for listening. I know. I mean, this is. I mean, I'm again saying like this is not a full-fledged course or workshop in ROS because that is not possible. This is a very big topic, and we are trying to just start with it. Okay. So for me also it's very difficult because all of you have different background, different experience. So it's very difficult to teach as well. Okay, so if you have any feedback, you can send to Tamim. Okay, so he will get back. Okay, okay then, guys. Good day. Okay. Yes. Bye, everyone.
Thank you, sir.
Yeah. Bye.
Thank you, sir.
Thank you, sir.
So guys, I will share the link when I get. Okay, thank you all. And then next day session is on the same time, 11 o'clock. Okay, goodbye.
That I'm sending a data called integer. Okay, integer data. So the data bus that is creating by the ROS programs are called ROS topics. Okay, ROS topics. The data bus creating by ROS nodes is called ROS topic. And the what is the purpose of this data bus? The purpose is like sending and receiving data. Okay, and we can assign a data type as well, so that only that kind of data will be flowing. Okay, so just understand what is a ROS topic is. ROS topic is actually a database, named database. Okay, through that we can send a particular kind of data. Okay, and so we have understood that what is a ROS topic is, and next is the kind of data flowing through the ROS topic is called ROS message. Okay, so here Lentin is the ROS topic and integer 32 or int32 is the ROS message. Okay, so we have gone through ROS nodes, then ROS topics, then ROS messages. Okay, then the next thing is yeah, so I think this is enough for current discussion. Okay, we will see more concept related to the ROS computational graph. Okay, so just understand that in a computation graph we have many nodes and those nodes are communicating with each other. So communication basically means it's exchanging some data. Okay, so in order to exchange data we have to create a database. Okay, so we can create database using ROS APIs. Okay, and we can name it. Okay, you can give any name. So here, for example, I have given Lentin as the named database, and the named database is called topics, and the data flowing through the database or topics is called ROS message. Okay. Okay, so if you want to communicate, if you want to send some data from one node to another, the first step is you can create a database or ROS topic. Then you can send or publish the particular data through it. Okay, and this node, maybe a program 2 or program 3, can subscribe to this topic. Okay, so program 1 is publishing a topic called Lentin, and program 2 is subscribing to the topic Lentin. Okay, so this is how we are commonly, I mean, these are commonly using terminologies while working with ROS. So publishing of a topic, then subscribing of a topic. Okay, then ROS message, ROS topic, then ROS nodes. Okay, so I think you got an idea about these three things. Okay, nodes, topics, and message. Okay, yes. So now I'm switching to the ROS equation. Okay, so I mentioned that in yesterday's session, I mentioned that the heart of the ROS framework is the inter-process communication. Okay, meaning using this capability of ROS, we can write programs that can able to send and receive data. Okay, it's very simple. Like using ROS API, you can send some data, and some other program can receive that data, right? So the first part is called plumbing, right? Plumbing or inter-process communication, which is the main part or heart of ROS framework. Okay, and the next three or next two is based on this capability, like this inter-process communication. Okay, so there are some tools available in ROS. Okay, in order to view or in order to debug the ROS computational graph. Okay, so maybe I can show you some example for that. So you can also try. So if your ROS environment is working correctly, like if the ROS core is working correctly, what you can do is just start the ROS core. Okay, just start the ROS core and open another terminal. Okay, so maybe I can do this in our normal terminal. That will be best. So this is a normal terminal. Let me take it. Okay, so you can open this terminal and you can create a tab here. Okay, if you press here, you can create multiple tabs. Okay, like our browser. Okay, so you have to take 3 tabs. Okay, and in the first tab, you can just start the ROS core. Okay, And if your ROS setup is working, then ROS core will be working. And you can type RVs. Okay, RVIS. Okay, so RVs, you will get a 3D visualizing tool like this. Okay, RVs. Okay, so the thing is that RVs is actually a tool, graphical GUI tool, basically. Okay, so the purpose of RVs is visualizing the ROS topics. Okay, so we have seen we can create ROS topic and we can pass any kind of messages through ROS topics, right? So imagine if you want to send some image data. Okay, so those kind of data can be visualized in this tool. Okay, so this tool is for visualization. Okay, you can simply visualize the data coming from each topic. Okay, I will show more demos. Currently, I just want to show this tool. Okay, so ROS is having some inbuilt GUI tools for visualization. Okay, one of the tool is RVs. Then another tool is called RQT. Okay, so these all are graphical tools. Okay, so there are many application for this tool as well. This is actually a 2D tool actually, so you can load various plugins. So in order to visualize an image, you can load these plugins. Okay, so yeah, so this is another tool. And more than that, we have command line based tools. Okay, command line means you can type it in the terminal. Okay, and you can use that tool. So there is no window for that tool. For example, I can show you ROS topic. Is it actually a tool? Okay, ROS topic. So what is this tool about? This tool is for finding the number of topics currently available. Okay, so if I'm doing ROS topic space list, I will get what are the current topics publishing or subscribing. Okay, so what I'm trying to say is there are many tools available in ROS, both graphical tools and also command line tools. Okay, so what is the purpose of this tool? The purpose is just debugging and visualizing the topics of the computation graph. Okay, so you know the computation graph, right? Computational graph simply means interconnection of different nodes in our computer. Okay, so in order to visualize the data through these topics, we can use this tool. Okay, not only visualization, but you will get all the information of the computation graph. For example, if you want to see what all are the nodes currently running, you can find it. Okay, and also you can visualize the computational graph as well. Okay, so visualizing means how these nodes are connected with each other. So we can even visualize it. Okay, so that's why we have ROS tools here. Okay, so the first part is called the plumbing. Okay, and plumbing, I mentioned, it's a heart of ROS, is mainly for the inter-process communication between different process in your computer. Then the tools are for debugging and visualization. Then the third one is very important one for us actually. So on the top of this inter-process communication, researchers actually build a lot of high-level features in ROS. Okay, high-level features means maybe I can play a video in order to understand. Let me start this video. Okay, so in this video, what you are seeing is a simulation video, okay, of a robot called MIR. Okay, and what you're seeing is you're seeing a high-level function called autonomous navigation. Okay, autonomous navigation. It simply means a robot can move from A to B without manual intervention. Okay, it can go automatically. We don't need to control it. So you can see in the video, I'm giving a goal position using my mouse. Okay, so I'm giving goal position in the map. So you can able to see it's actually planning a path. Okay, and you can see two software here. This is Gazebo and this is RVs. So I mentioned that RVs is called ROS visualizer. It is mainly for visualizing various data from topics. Okay, so here you can see robot model, then map, then path. Okay, so we can call it as a capability in ROS. Okay, so if you want to create this kind of application, then you can use ROS software and you can customize it. Okay, so this is the higher level features in ROS. Okay, so the fundamental, the core part of these functions are the inter-process communication. There are different nodes working in order to accomplish this task. Okay, and you can able to see the simulation here. Simulation. So the robot is simulated in the simulated environment, and the visualization is showing in the RVs. Okay, so I can show you another capability called manipulation. So this is navigation, and I can show you the navigation as well. Let me decrease the volume. Okay, so here we are showing an example for manipulation. Manipulation means maybe pick and place kind of operations. So if you have a robotic arm or something, if you want to take some object from A to B, okay, in navigation it was like going from A to B, but in manipulation, if you want to move or if you want to pick an object and place it in another position, we can call it as a manipulation, and we are mainly using robotic arms for that. I think these kind of robots are familiar to you. Okay, so how can we move the robot from position A to position B? That's actually a very big challenge. You maybe heard about the inverse kinematics algorithms, which is used for moving the gripper or end effector of the robot. Okay, so those are like high level things. Okay, so if you are like want to implement these kind of IK, it will take a lot of time from scratch. Okay, but what ROS does is that it is giving some existing software stack to us, and we can simply customize it, and we can able to achieve this kind of application for your robot. Okay, interesting, right? So we can implement this kind of high level features like manipulation, pick and place with vision. Okay, you can include even cameras for pick and place. Okay, and also perception, meaning if you want to work with LiDAR or cameras, you can able to create this kind of stuff. Like this is actually creating the 3D map of an environment. Okay, using a Velodyne sensor, which is a LiDAR. So yeah. Any confusion, guys? Okay. So in this video, you can able to see a car is driving on the street, and it is having a LiDAR on the top of it. So using ROS, we are basically capturing this the 3D information and creating the map of the environment. Okay, so this kind of application can be also possible. And build your own autonomous mobile robot, or pick and place robotic arm, or some perception like map building. Anything is possible. Okay, so that is the important one. So this may be useful to you, because if you are planning to prototype any projects in your maybe as a main project or mini project, you can think about using ROS. Okay, but you have to learn more, then only we can do the customization. Okay, yes, and finally, ecosystem. Ecosystem simply means if you have any doubts related to programming or anything, you might search in internet, right? So you may be getting some Stack Overflow link or something, right? So that is actually called ecosystem. Like if you have any issues, there is a community to support you, right? So similarly in ROS, if you have any confusion or something, there is a big community around it. Okay, so there is a great community, then a lot of developers. Okay, so the ecosystem is very strong. Okay, so if you have any confusion, I'm sure that you will get the solution. Okay, from the web mostly. Okay, so this is actually called the ROS equation, and you will get this equation from the ROS website as well. Okay, so the main part, the heart of ROS framework is the communication, inter-process communication, and using that, in order to inspect these computational graph, we are using tools. Okay, and on the top of this inter-process communication, we have built a lot of capabilities. Okay, existing capabilities are there, and we can simply use it by customizing it. Okay, so you don't need to implement everything from scratch. Okay, and there is a strong ecosystem around it. Okay, so these are the main things associated with ROS framework. So so here I think this is you will understand this. Actually, we are installing ROS on Ubuntu, and Ubuntu may be placed in a computer that is placed in the robot. Okay, so robot will have some computers, and the computer will maybe running Ubuntu, and on the top of the Ubuntu we can install ROS. Okay, and using ROS APIs or functions, we can create apps. Okay, apps or programs using C++ and Python, and you can achieve these kind of applications. Okay, so this is what happening in ROS. Yeah, so our application is here. Okay, and so this is an advanced block diagram. So you can see instead of ROS, we have ROS client libraries, middleware, and all. So basically, ROS consists of the communication middleware and the client libraries. Okay, so I will explain what it is. So the client libraries are the libraries that is giving to us for programming. Okay, for example, if you want to program using ROS, we have a library called ROS-CPP. Okay, so you can use the ROS-CPP, and you can include the ROS-CPP header files in your program, and you can implement ROS topics, ROS messages, then ROS nodes, everything. Okay, also ROS-Py. ROS-Py is for Python, so you can import the Python module, ROS Python module, and you can work. You can create your own ROS programs. Okay, so this is the ROS block diagram. I mean, here is the application layer. Okay, and these are the things that we have seen. Okay, the computational graph is here, and individual process in ROS is called ROS nodes, and each nodes are communicating with each other. Okay, so program 1 is publishing, program 2 is subscribing. Okay, so program 1 can publish a topic called Lentin. Okay, and program 2 can subscribe to a topic called Lentin. Okay, any confusion, guys? Okay, fine. Okay, so we have seen topics, ROS messages, right? Okay. Okay, so I think this is enough to get started with ROS. Okay, publishing, subscribing. Okay, and I just want to explain one more concept. After that, we can do some hands-on session. Okay. Okay. Yes. So we have discussed that using ROS, the programs can able to communicate, right? So how this is possible actually? Okay, how this is possible? How two programs can communicate with each other? So okay, so that is the next thing that I am going to explain. It will not take much time. Okay, so the thing is, so I mentioned that the one of the command called ROS core, right? ROS core. So the ROS core is actually a broker program. Okay, so in arranged marriage, okay, in arranged marriage, Okay. Can you hear me, guys? Hello?
Yes, sir.
Okay. Okay. Yeah. So okay. So in arranged marriage, there will be a broker. Okay. And the broker is having the profile of girl and boy, right? And I think there is some network issues. I hope you can able to hear me, right? Let me change my. Yeah. Okay. Can you hear me, guys?
Yes, yes, sir.
Okay. Oh, sorry for the interruption. I'm not sure why what happened. Okay. Yes. Uh, in case of arranged marriage, we have a broker, and that broker is having the profile of girl and boy, right? So nowadays, broker is replaced by matrimonial site, right? So the boy and girl will create a profile, and if there is a match, then they can connect with each other. Okay, so just take the condition or the case of broker. So imagine the master is a broker. Okay, master here is a broker, and talker is a boy. So when a boy want to get married, the boy will give his details to the broker and also his requirements. Okay, then there is a girl, and girl also share her details and her requirements. So requirement is like girl will say, I need a rich guy with very intelligent, very handsome, those kind of stuff. Then boy will say, I need a very fair, beautiful, intelligent, rich, those kind of stuff, obviously. Okay, so what happening is that master is having both the profile. Okay, then master or the broker will find a match. Okay, then um he will exchange the data or the profile to either girl or boy. Okay, and if there is any match found, if one guy is interested, then they will start connecting. Maybe they will start texting, and then is there any need of broker? No, right? So the similar situation is happening in ROS communication. Okay, so in ROS there is a broker program called master program. Okay, so when you start ROS core, what you are doing is you are starting the broker program. Okay, and what is the function of this broker program? The function of the broker program is connecting different programs. Okay, so when you start the broker program like this, you can start if a program called talker. Okay, no need to bother about the commands. I'm just executing an example. After this example, I will explain. So I'm starting the boy program. Okay, so boy program will like it's actually running. Okay, it's running, and now I'm starting the girl program. Okay. Okay. So now you can see the boy and girl is got connected with each other. So how we can detect that is here in this program, it is sending a data called hello world, some integer value. Okay. And in girl program also, we are getting the same. Okay. So that means these programs are communicating with each other. And if you are closing the master, this communication will goes on. Okay. So, and so let me close this stuff. Okay. And I'm not starting master now. I'm just starting talker. Okay. Talker is one program, say it's a boy program. So here it talker is saying failed to contact master. Okay, if you simply run Docker, it will be saying like this. And I'm starting girl program here. So here it's the girl program is also saying fail to contact master. Okay, so that means if you want to run a ROS based program, okay, you have to start the ROS master. Okay, then only the communication between two nodes will happen. Okay, so if we start the ROS call, you can see it started the communication. Okay, we can do this example after this explanation. Okay, so I think you got an understanding how the communication in ROS happening. There is a broker program. Okay, so you have to start this broker program first before starting any programs in ROS. Okay, so after starting this, we can start the other programs like Docker or Listener. Okay, then internally these programs are communicating with master, and after that the master will share the details, then this will start communicating. Okay, so after communicating, don't stop master. Okay, because if you want to work with any other nodes or something, the master is essential actually. Okay, so master, you should be always running ROS core or ROS master. Okay, in ROS, then you can run any nodes. Okay, so this is how the communication in ROS happen. Okay, mainly through the ROS master or the broker program. Okay. Okay, so we understood that how the communication happened. Now we can do some hands-on. Okay, so I hope most of you have the ROS based system. Otherwise, if you have any issue with the ROS installation, I can mention a few issues with the installation. So one of the issue that sent to me was could not get log var lib apt list log. So this is actually, we can solve it in different ways. So one of the easiest method is maybe you can restart your system. Okay, restart your system, and sometime this will happen because there is an upgrade software running in background. Okay, I think this one, software update. Okay, so in Ubuntu, what happening is that we can't use two package manager at the same time. Okay, then this will it will show this error. Okay, so either restart and try again. Otherwise, you can delete the log file. Okay, so if you just copy paste that issue in Google, I think you will get to know the step. Okay, you can just delete one file and it will work. Okay, the next issue of the installation is like ROS core, some launch issue. So I suspect this is because of the improper installation. I think, okay, you can reinstall the ROS again, like you can follow with the same commands. Okay, and you can try it again. Okay, okay, so we can start doing some hands-on session. Okay, so in order to work with ROS, we mostly working with the Linux terminal. Okay, so by default, Linux is having a terminal application. Okay, this is a terminal application, and if you want to get a different terminal application, there are different terminal applications available. There is a terminal application called Terminator. Okay, Terminator. So you can install the Terminator using this command. I'm not sure this will work for everyone, but you can try. Okay, so sudo apt install Terminator means you are going to install the app called Terminator. Okay, I have already this tool available here. This is the Terminator. Okay, and the advantage is that you can create multiple terminals in the same window. Okay, so the command was sudo apt install Terminator. Okay, and if this is not working, don't worry. What you can do is, here there is an option for creating tabs. Okay, so in order to create multiple terminal, you can just keep on adding tabs. Okay, so if you have a good internet connection, you can try this Terminator. Okay, and you will get this. Okay, others can work on the tabs. Okay, yes, right. Okay, so we can start. So the first example that we are going to try is the talker and listener example. Okay, so that we have seen here. Okay, I will explain what is happening. So as I mentioned, the first program that we have to run before starting the ROS program is ROS core. Okay, so I'm starting the ROS core here. Okay, so ROS core is running. Okay, so now what we can do is we can start ROS programs. Okay, so currently we don't have any ROS programs. Okay, we don't have any ROS program written. So in order to test the communication, whether in order to make sure everything is working fine, ROS actually provides with some examples. Okay, some example programs like Hello World. So what you have to do is you have to run that example. Okay, so the examples are talker and listener. Okay, so in order to run the talker, we can use this command talker. Okay, I will explain the command actually. So I mentioned that ROS actually provides with lot of command line tools. Command line tools. Okay, so first part of the ROS was plumbing, second part was tools, right? So that include command line tools and graphical tools, right? So in order to find command line tools in ROS, what you have to do is just type ROS, okay, and press the tab key. There is a tab key in your keyboard, right? Twice. Okay, so just type ROS and press the tab key twice. Okay, so you will get different commands starting with ROS. Okay, this much of commands are providing by ROS. Okay, so I'm using one of the command in ROS, one of the tool in ROS called ROS run. Okay, so if you want to know about this tool, just type ROS run. Okay, or you can use ROS run help. Both are same. Okay, so what ROS run does is that this command or this tool is helping us to start a ROS program. Okay, ROS program. Okay, and in ROS, actually, the programs are organized as a thing called packages. Okay, so I can show you that. So in order to write a program in ROS, first what we have to do is we have to create a workspace and then a package. Okay, and don't worry, I will explain. Let me take that. Okay, so you will get an understanding. I think Catkin. Okay, yeah. So if you are planning to start writing. Okay, yes, hope you can hear me. Yeah, so in order to start working with ROS, the first thing that you have to do is creating a workspace. Okay, workspace is nothing but a folder. Okay, and inside the folder, you can create a package. Okay, so I'm not explaining about that, but I'm just giving an idea. Okay, don't worry, I'm just giving an idea. So inside the package, we are storing our programs. Okay. Okay, so each programs are available at the ROS package, in the ROS package. Okay, so this is an example package. Inside that we can see different programs. Okay, then we can build these packages and we can create the executable. Okay, so this is a structure of ROS programming. Like first we have to create a workspace like this, just a folder. And inside that there is an SRC folder. And inside that there are many packages. Okay, and inside the packages we have another src folder and many programs. Okay, it can be C++ program or it can be Python programs. Okay, Python programs is organized in script. Okay, so you can see ROS based script here, and here is a C++ program. Okay, so here what you are seeing is the ROS CPP underscore tutorial is the package name. Okay, that is given by ROS installation. So when you install ROS, you will get this package already. Okay, so ROS run space package name space the executable name. Okay, so these are already available in your ROS installation. Okay, ROS run space ROS CPP underscore tutorials space Docker. Okay, if you do that, the Docker program will start running. Okay, so we don't know what is happening in Docker program. Okay, we don't know. Then there is another example program called listener from the same package. So ROS run space ROS CPP underscore tutorials space listener. Okay, so we can run that. Okay, so you get to know these programs, like the messages that is seeing here is showing here as well. Okay, so now let's see what is happening. Okay, what is happening literally. So in order to visualize the computational graph, okay, currently these programs are working, right? So first we can check the computational graph. What is the computational graph? Okay, so don't worry about the command, just create the idea. Okay, so I have a GUI tool called RQT. Okay, RQT, I think I have already shown to you. So using RQT, I can visualize the computation graph. Just a second. Okay, so this is the computational graph. Okay, so anyone can explain what is happening now by seeing this computational graph? We are running like two programs, right? And this is the computational graph. So anyone can explain what is happening now in the background? Anyone? It's actually very simple. Any idea, guys? Any idea?
Sir, Docker send a message or anything to listener.
Yes, correct. So I mean, by simply looking at this, we can see talker is sending something and listener is receiving that, right? So in ROS terminology, what we have already discussed was talker is publishing a topic, right? Then listener is subscribing to that topic. Okay, and what is that topic name here? The topic name is chatter. Okay, so the talker and listener are two programs basically, and it's already compiled and the executable is already available. Okay, so we can simply run it, and this is an example program. And what happening is that in the computation graph, the talker is actually a ROS node and listener is also a ROS node, and talker is publishing a topic called chatter. Okay, and chatter and chatter is subscribing by listener node. Okay, so this is what happening in the background. Okay, so I think you got an idea about the computational graph. Okay, computation graph. This is a computation graph. Okay, and using the tools, command line tools, we can find a lot of things. We can debug the ROS computation graph. For example, if we want to list down the number of topics, just do ROS topic. ROS topic is a tool. Okay, ROS topic is a tool. So just do ROS topic space list. So you can see the topics available is chatter. Okay, so I'm doing ROS topic space info space chatter. Okay, so if you do that, you will get to know what is a type of message that is flowing through the chatter database or chatter topic. Okay, so the type of message is string. Okay, you can able to find it's actually transmitting a string data type. Okay, so similarly you can list down the nodes. Okay, you can find listener and talker here. Okay, these are the active nodes in the ROS computation graph. Okay, so like that you can find a lot of things using the ROS tools. Okay, so imagine this is a condition for 2 nodes. Okay, imagine we have 10 or 20 nodes are simultaneously working. Okay, then the graph will be more complex. Okay, I will show you some graph maybe in the upcoming demos. Okay, so this is a very basic example for ROS. So, that these 2 programs, okay, these programs are able to communicate, right? And you have seen the computational graph, okay, and you can list down the topics, okay, and you can even visualize the data or just get the data flowing through the topic as well. So you can see the data from the topic. You can just this is what happening. Okay, so using ROS tools, you can inspect the ROS computation graph. Okay. Yes. So I think you got an idea how the ROS master work and the ROS nodes, ROS topic, ROS messages, okay, and ROS computational graph. Okay, so this is the example that we have discussed. Okay, this is a I mean already inbuilt example in order to test whether the ROS system is working fine or not. Okay, so now we can go to some interesting examples. Okay, so how many of you heard about logo programming? Logo programming. Anyone heard about logo programming, guys? Logo programming, anyone? Any idea? Okay, so I think the logo programming is actually taught in high school, okay, for creating the programming logic or developing our programming logic. Okay, so basically it's not like C, C++. Okay, we can give instructions like this, repeat or forward, backward, like that, and there will be a turtle on the main workspace. Okay, so if you say go forward 5, then the turtle will move, go forward 5, maybe 5 meter or something. Okay, so this is a good programming language for teaching programming basically. Okay, we can't use it for professional purpose, but it's only for developing our programming ability. Okay, so in order to understand or in order to work with ROS concept like ROS topic, ROS messages, those kind of stuff, we have a logo programming kind of tool called TurtleSim. Okay, TurtleSim. So which is mainly designed for learning ROS. Okay, so the concept is that inside the TurtleSim there is a turtle. Okay, and turtle is actually a robot. Okay, it's a mobile robot and moving in a plane. Okay, moving in a 2D plane. And if you want to move this robot, you have to give the velocity commands. Okay, so imagine you are giving linear velocity to this robot, then the robot will move forward. Okay, if you give angular velocity, it will rotate. Okay, and if you give linear and angular velocity, it will be moving in a circle. Okay, so this is the idea. So we have the turtle sim in our ROS installation, and you can use this tool to learn ROS. Okay, because you have to use the ROS command line tools, then concepts, then only we can proceed to the programming parts and all. Okay, so so everyone, if you are seeing, I mean, if you have the ROS setup, what you have to do is, in order to close the listener and talker, you can just press Control C. Okay, Control C to quit that program. Okay, you can quit all the programs. Okay, you can quit or you can just close the tab. That is also fine, but I will prefer the Control C. Okay, to terminate everything, including ROS code. Okay, so currently we are going to see how to start with Turtle Sim. Okay, and how to play with it. Okay, and this is mainly for improving your ROS knowledge. Okay, this is a tool. So first, what you have to do is start the ROS code. Okay, so the ROS code is running. Now I am starting the Turtle Sim node. Okay, Turtle Sim is actually a ROS node, so I can use the ROS run command. Then there is a package called Turtle Sim. Okay, then Turtle Sim node. So if the command box is enabled, maybe, I mean, command box, maybe I can able to copy paste it, but you can see this, right? You can ROS run space Turtle Sim space Turtle Sim underscore node. So just type it. I will wait. Okay. Maybe I can show you the command. So this is the command, guys. Okay. You can try to launch these two commands. So ROS core in one terminal, and don't quit that. You can create a new tab and run the Turtle Sim node in the second terminal. Okay. Is that working, guys? If it is working, just raise your hand. Yeah, any confusion? Okay, I hope yeah, a lot of students got able to working. Okay, yeah, great. Okay, so I hope that is clear to you. Okay, so if everything is working fine, you will get this window. Okay, so this is the Turtle Sim window, and you can able to see the robot. Okay, and now how to play with this? How to play with this? That is a next question, and how to play with this and how to improve our ROS knowledge using this tool. Okay, so in order to work with this, first we can check the topics. Okay, what are the topics currently available? So if you just check a ROS topic space list, you can able to see different topics from the Turtle Sim. Okay, so these are all are the topics that is providing by Turtle Sim. Okay, if you do,
can you show the code once again for Turtles? Opening
yes.
that.
Sure. So maybe I can type it here. This one. Okay.
Okay, sir.
Yeah. So if you do the ROS topic list, you can able to see some topics. Okay. If you do ROS node list, you can see the Turtle Sim. Okay, so this is actually the ROS node, right? And there are many commands associated with ROS node. Okay, so if you simply type ROS node in one of your terminal, okay, you can see, you can list down the nodes, then we will get the info of the nodes. Info means what are the topics the Turtle Sim is publishing and what are the topics that Turtle Sim is subscribing. Okay, so just do ROS node, then info space Turtle Sim. That is a node name. Okay, so each node will have a name associated with it. Okay, so you can just give this. Okay, maybe I can show this command here so everyone can type it. So this is a command that we are currently executing. Okay, so if you do the ROS node space info space Turtle Sim, what you can find is you can find the node name, then publication, meaning these are the topics it is publishing. Okay, and these are the topics it is subscribing. Okay, so the topics that is publishing is the position of the robot. Okay, and there is a color sensor mounted on this robot. Color sensor, like if you work with line follow robot, there is a color sensor, right? I mean, we can do it in many ways, but so there is a color sensor associated with it. So these topics are publishing by Turtle Sim, and it is subscribing for subscribing the velocity commands, meaning if you publish a velocity command in this topic, then Turtle Sim will subscribe it and move the robot. Okay, I will show you that. Okay, then only you will understand. So okay. So in order to close any terminal, you can use Control C. Okay, and in order to clean your terminal, you can press Control L. For example, I'm just type something, okay, in my terminal, and I can use Control plus L to reset or clean. Okay, so Control C to quit the program and Control L to clear the terminal. Okay. So this is a command that we are going to execute now. Okay. So make sure ROS core is running, Turtle Sim is running. Now I am running the Turtle Sim, Turtlebot, Turtle Teleop key. Okay. You can type this. Okay, I'm just mention the command here. So I'm using my keyboard arrow keys. I'm just using my keyboard arrow key, and you can able to see the turtle is actually moving or the robot is actually moving. Okay, basically we are starting a program called Turtle Teleop key. What it does is that it will read from the keyboard, okay, and send the command velocity to the Turtle Sim topic. So if you just move the keys, it will publish linear and angular velocities, then the turtle will move. Okay. So basically, so let me show you how the computational graph works. So here you can able to see we have the Turtle Sim node on the right side. Okay. And we have the Teleop turtle node on the left side. Okay. And the Teleop turtle is publishing some topic called turtle1 command velocity. Okay. And Turtle Sim is subscribing to that topic. Okay. And there are some interesting use cases like if you want to know about this topic, let me. So just let me know this command is working, guys, like turtle teleop key. Okay, and you can use your arrow keys to move the robot. Just press the mouse here, then move your arrow keys. Okay, is that working, guys? Any issue? Any confusion? Is that working for anyone? Is this teleop keys working? Okay, okay. Yes. Yes, I think it's working for someone. Yes, good. So if you have any difficulty, I think this session is recorded. So don't worry, you can just replay and you can able to see this command as well. Okay, so you can move the robot. Okay, and so let me list down the topics now. Okay, so we have these topics, and if I'm doing ROS topic info space command velocity. Okay, so this topic is publishing by Teleop Turtle, okay, and subscribing by Turtle Sim, right? So if I'm doing ROS topic space info space that topic, you will get the publisher of that topic is Teleop Turtle. Subscriber of that topic is Turtle Sim. Okay, so I think I can now I can explain why we use Turtle Sim for learning ROS, because using this tool we can learn these command line tools. Okay, there are many command line tools available. Okay, so you can practice all these command line tools using Turtle Sim. Okay, so this is the best way to learn ROS concepts. Okay, so I'm just pausing here. So this is just a start. Like you using Turtle Sim, you can do a lot of stuff. Okay, maybe I can show some projects that done by my ROS course members. Let me take that. So you will get an idea the possibilities of the Turtle Sim. Okay, so they have done this for learning ROS. So I can start from the ping pong game. Okay, so here you can see one of the course member, he have done he implemented a ping pong game. Okay, this is actually very difficult. Okay, so using the ROS concepts, he implemented the ping pong. Okay, so that is one project, and here another guy tried drawing Iron Man in the turtle sim. So basically we are giving the picture of Iron Man, and a swarm of turtle will draw this image. Okay, so on the right side we have the reference image. Okay, and on the left side a swarm of turtle will draw this image. Interesting, right? Okay, and another project, snake game. Okay, so these are very interesting projects. Actually, I didn't even expect they will do this kind of work, because these are like exceptional work using Turtle Sim. Okay, I think it's actually loading. Yeah, it will take some time, I guess. Okay, anyway, like I can give this link to you so that you can just go through it. So there are many projects that you can do using Turtle Sim, so that it will increase your ROS know-how. Okay. Okay. Let me just pause it here. So these all posts are available in my blog, Robo Academy. Okay. Yes. Okay. So I think that will be a good start for you. Okay. To start with ROS concepts. Okay. Now I can show you another demo using Turtle Sim. After that, we can do some serious stuff like how to build the robot using ROS, and some demos, simulation demos and all. Okay. So it will take, I think, around 30 minutes more to complete it. Okay. Okay. So let me start a demo in Turtle Sim. So I'm just closing everything. Okay. I'm taking a new terminal. just splitting. So instead of splitting in your terminal, you can create a tab. Okay. Okay. So now first step is ROS core. Then I can start the turtle sim. Okay, this turtle sim is here. Now I can start another node, which is the demo program. It's called Draw Square. These all are some existing programs available. So this demo is just showing the robot is drawing a square. Okay, so we are actually publishing some velocity to the turtle sim in order to move linear and in order to rotate. Okay, so you can see the robot is moving like this. Okay, so this is actually in simulation, but you can do the same in actual hardware. I mean, if you have a real robot like this, you can set up everything, and if you give the linear and angular velocity, the robot will move like this. Okay. Yes. So maybe you can try that example. I can show you the commands. So in the first terminal, start ROS core, then the turtle sim node, then turtle sim space draw underscore square. Okay, you can just try that. And if anyone getting it, just raise your hands. Okay, I think some of you are already start getting it. Yeah. Okay, so this is the draw square example. So I know some of you have confusion and difficulty in executing it. Okay, don't worry. These things will, I mean, it will take some time. So I think you can watch the recorded video again. Okay, yes, that would be good. Okay. So now we have seen how the turtle sim works, and we have seen some demos as well. So we have two topics left. One is interfacing ROS into a real robot, and then demonstrating robot in simulation, demonstrating different capabilities in simulation, and also like some more topics like the job opportunities, obviously. Okay, so let me jump into interfacing of a real robot to ROS. Okay, yes. So we have seen the turtle sim, and you know, this is for learning ROS concept. Now the question is how we can create a robot and work with ROS. Okay, so in order to demonstrate this, I just created a small robot and interface into ROS. Okay, so we can interface a robot into ROS in different ways. Okay, basically, if you check the turtle sim example, in order to move the robot, what we have done was we have given the linear and angular velocity, right? So similarly, any robot can move. I mean, if it is a mobile robot moving in a plane, you can control using like linear and angular velocity. So this is a very simple example how I created a ROS-based robot. Okay, just to, I mean, just moving using keyboard and doing some A to B movement, simple A to B movement. Okay, so these are the components that I have used. This is called the magician kit. Okay, and there are two wheels and one caster wheel, and there is encoders in order to detect the velocity, and if you have the velocity, you can integrate and you can find the displacement. Okay, so this is a circuit. Basically, I'm using an Arduino Mega. Okay, and I have used a Bluetooth module in order to communicate with the PC. Okay, so this is a very simple example. If you are building advanced robot, you can put a Raspberry Pi and you can install ROS on your Raspberry Pi and control it. Okay, so in this robot project, I'm simply working it with an Arduino board. Okay, and this is not a complex robot, but this is just for a demonstration purpose. Okay, so you can able to see we have an Arduino Mega board with a Bluetooth module. Then Arduino is interfaced to encoders, okay, for detecting the velocity. Then we have a motor driver, which is driving the motor, okay, and there is a supply voltage and there is an ultrasonic distance sensor as well. Okay, so this is a basic circuit. So the communication between the robot and we have a PC as well. So that PC and robot is happening over the Bluetooth module. Okay, and the complete ROS based software is running on the PC itself. Okay, so there is no ROS based program running on the robot, and the Arduino Mega basically receiving the commands from the PC and sending the data to the PC as well. Okay, so this was the prototype. I just made for a demonstration, so you can see it's very bad. The wiring is also very bad. So you can find the motor driver, Arduino Mega, Bluetooth driver, Bluetooth module, then ultrasonic and battery. Okay, and this was a software actually. Okay, don't be too confused because the robot here on the left side. Okay, and this is actually Bluetooth. Okay, the interfacing from robot to maybe I can just use my pen. Okay, so this is the robot side and this is the Bluetooth. Okay, and these are programs running on the on my PC. Okay, so these all
Hello, sir. Sir, I think you
yeah.
are muted.
Yes,
Okay.
yes. I'm not sure how this is automatically happening because I'm not muting it. I'm not sure how this is automatically muting. It may be because of my settings. I'm not sure. Okay, so I just want to show you like how I created an application with the help of ROS. Okay, so the main application is like simply moving the robot using keyboard, okay, from PC, and also um, you can command the robot to go to some position with respect to the robot. Okay, so the robot will move to that position. Okay, so there is no obstacle avoidance or something, just obstacle detection. If there is any obstacle in front, it will stop. That's it. Okay, so I just made this for demonstration purpose in order to understand like if we have a different programs, you can in using ROS we can write different programs for doing different stuff and they are communicating with each other and sending different data. Okay, so this is an example for a robot that is working using ROS. Okay, there are many examples like autonomous navigation. Those are some more advanced, so that's why I didn't mention it. Okay, yes. So after this, we can maybe we can go to a little history. Let me. Yeah, we have discussed the capabilities and all. Okay. Yes. So just a bit of history. Maybe it will not take much time. So the ROS project actually started in 2007. Okay, not as the ROS project. Its name was Switchyard. The later there is a company called Willow Garage. It's a research institute. So from 2008, the ROS project started. Okay, and in 2030 they have shut down. and currently it is maintaining by Open Robotics. Okay, so ROS 1, ROS 2, Gazebo, all these software are maintained by Open Robotics. It's in US. So these are some of the robots that created by Willow Garage. Okay, so this is the current team of Open Robotics who are maintaining ROS. Okay. Okay, then why we are using ROS? I think I have mentioned that it is open source. Obviously, there is no, and also free. Then we can implement this kind of modular kind of programming with publishing, subscribing method. And there is a great community around it, and even we can run different programs in different computers. Okay, we can create a network, and if we have a very complex robot, we can do the computation in different distributed distributed set of computers. Okay. So now there are ROS distribution. So like Linux distribution, like Ubuntu, Debian, then Fedora. Okay, so those are called the Linux distribution, right? So similarly, there are naming for ROS as well. It's called a ROS distribution. So in each distribution, we have set of ROS programs. Okay, so from 2010, you can able to see different versions like ROS Box Turtle, Sea Turtle, Diamond Black. I think I have worked from Diamond Black. Okay, so Electric, Furate, Groovy, Hydro, Indigo, Jade, Kinetic, Luna, Melodic, and Nautic. Finally, okay, so these are ROS 1. Okay, so currently the latest ROS 2 distribution is ROS 2 Foxy and ROS 2 Galactic. Okay, Galactic is the latest one, but ROS 2 Foxy is a stable one. Okay, it is you can install ROS 2 Foxy in Ubuntu 20.04. Okay, so you can install ROS 1 Nautic and ROS 2 Foxy in the same system. Okay. So these are some of the robots supporting ROS, meaning the robots are completely working using ROS. Okay, so this is one robot from NASA. It's called Robonaut 2. The initial prototyping of the software was done using ROS. Okay, so now PR2, Turtlebot 2, and Turtlebot 3. These are very famous educational robot. So if you can buy this kind of robot, you can practice, okay, what you have learned in ROS. Then there are many robots like this, like both service robot, then robotic arms, mobile robots. Okay. Then also there are many sensors supported by ROS, meaning you can simply interface these sensors into a computer and you can run some ROS program. So that ROS program will read these sensors and publish in some topics. Okay, so these are some sensors. USB cam, obviously, then some depth cam. So these are, the list is very less. There are many robots and sensors supported in ROS. So these are some IMUs supported, and also you can interface some IO board, input output board, like Arduino, Tivasi board, and each board can act as a ROS node. Okay, so you can search about ROS Arduino, so you will get some reference. Okay, and these are some of the libraries supported, like the ROS is interface to OpenCV, meaning I mentioned that we can send images, right? One program can send image message to another program, right? So using the OpenCV ROS interface, we can convert these messages into OpenCV data type and process it. Okay, so these all are advanced concepts. So there are interfacing of OpenCV and Point Cloud library. Okay, and now the important one for you, who all are using ROS. Okay, so here the list is again it's not complete, but in my opinion, many companies are working on ROS, mainly the vendors. For example, if a company like Intel, they are manufacturing different cameras like depth cameras, then normal RGB camera. They are providing sensors. Okay, so they are also providing the ROS driver. Okay, so these companies are working with ROS as well. Okay, so there are different branches, there are different teams working on ROS. Okay, and you know, like companies like BMW. I mean, the list is not complete. I mean, Bosch. Then even in TCS, Infosys, there are robotics teams. Okay, I think for TCS there is a team in Bangalore. Okay, one of my friend is working there. So they are also working in ROS, ROS 1 and ROS 2. Okay, so many companies are working in ROS. Mainly, I found in US there are many companies, including this autonomous navigation, robotics. I mean, self-driving cars mainly. Okay, in India also there are a lot of MNC and also startups. Okay, so ROS is using by most of the roboticists like researchers, students. Then even companies are adopting ROS framework, and a lot of hobbyists are working. Okay, then what I mentioned was like the vendors, those who are providing robots and sensors to us. Okay, and job opportunities. I will say, like, if you want to explore a lot of opportunities in robotics, in US and UK, I think many opportunities. In India also there are, but compared to other countries, it is less. Okay, so if you can do a master's in robotics or something from US or UK, I mean not UK, from Europe, I think at that time you may need the ROS framework as well. Okay, for implementing stuff. Okay, so there are many opportunities. So this is actually an job listing from Hyperloop. Okay, so you can see the ROS skills. They need the ROS skills. Okay, similarly, if you just search for robotics engineer, most of the position needs C++, Python, ROS, OpenCV, those kind of skills. Okay. And regarding the future scope, so when the computers invented, the main breakthrough was a software, right? The operating system. So similarly, a robot is actually a hardware, consists of a sensors and actuators. But in order to give a life to it, we have to write efficient software, right? So that's where the importance of ROS comes. Okay, ROS is actually a very popular tool. I will say it's actually a tool to program robots. Okay, so I will say there are a lot of traction that ROS that is getting for ROS framework. There are a lot of opportunities as well. So I will say if you have a basic ROS knowledge, it will be helpful while working for working as a robotics engineer or a robotics researcher. Okay. And if you want to explore the possibilities, different possibilities or different new technologies happening around ROS, you can search for ROSCon. Okay, this is an annual conference happening. So ROSCon, in ROSCon, there are a lot of talks, new talks related to ROS. Okay. Okay, so yeah, that's it. And if you want to get updates related to ROS, I think the better will be ROS Discourse. Okay, maybe I can show you that. If you just search for ROS Discourse, you will get this link, discourse.ros.org. So in that you can see the latest updates. Okay. Yes. So now we can start seeing some demos. Okay, in simulation as well. Yeah, mainly in simulation. And yeah, let me show you some video demos first. So here, this demo was done in Willow Garage, and the demo is about the robot is playing the pool. Okay, I'm just seeking. Okay, so you can just watch this video. So basically, the researchers in Willow Garage, they are using ROS in order to do this stuff. The robot is playing the pool. It's not simply hitting it. There is a camera on the top of the pool, So the camera will detect these balls, and there is a planner algorithm running, and after planning it will be feeding into robot. Okay, so the robot will hit the ball in a particular angle. Okay, so this is the planner algorithm, you can able to see it. Okay, so there are many demos, ROS based demos available in YouTube. Just search for Willow Garage demos. Okay, you will get it. Okay. Yes, so this is one demo called Pool Shark, and there are many video demos. I'm not playing everything. This is called the Turtlebot 2. So there is an application running called People Following. So there is a computer inside the Turtlebot 2. There's a netbook placed, and there is a depth camera called Kinect. So it is mainly using for education and research. So here the Turtlebot 2 is following PR2. Okay. And one more demo, fetching the beer. This is an interesting demo as well. So the researchers in Willow Garage, they are trying to procure beer from the fridge. So they created a code so that the robot will go to the fridge and pick up the beer bottle. Then they will bring this beer to the table. So as you can see, these all are like interesting application, but these all are not very easy. Okay, it's very difficult to implement. Okay, and you can see it's playing in 5x, so it is super slow. Okay, very difficult to open a fridge and taking a bottle from that. Okay. Yes. So now I can show you some real world simulations. I mean, I'm just executing some simulation. So in the meantime, you can ask doubts. Okay, so if you have any. So after that, I think we can conclude. After showing these demos using navigation and manipulation, I think we can conclude the session. So in the meantime, you can ask doubts. Let me know if you have any doubts, guys. So now what you are going to see is a simulator called Gazebo. Okay, and inside the simulation we have a robot called MIR. Okay, and MIR is using in warehouses. Okay, this is the simulation environment. Okay, and what I'm trying to show you is the navigation. Okay, basically like going from A to B. I think I have already shown you the video of that. So I'm just starting some commands using the command line tools. You can see the importance of command line tools now. And finally, I'm opening RVs in order to visualize. Okay. Okay, so this is RVs, and you can able to see the robot. Okay. And now I'm giving a goal position in RVs. So maybe here. Okay, so it will take some time to path plan because I'm working from VirtualBox, so it's not very efficient like running from a real PC. So after some time, you can able to see it's planning a path and following that path. Okay, So this plan is executing in the simulation world. Okay, so you can able to see it's moving to that position. Okay, by avoiding all the obstacles. Okay, you can able to see it's detecting. It is having laser scanner, 360-degree laser scanner. So using that, it is avoiding all these obstacles. Okay, and the green path is called the global path, and there is a red path as well that is called the local path. I mean global plan and local plan. Okay. So this is a simulation demo of the navigation capability of the robot, autonomous navigation. So you can also implement this kind of functional, this kind of application in ROS. Okay. Now let me close this and I can show you the manipulation. Let me close all this stuff. Okay. Let me start and simulation. Okay. So in this demo, you can able to see a robotic arm. Okay. It's called the Panda. Okay. It will take some time to load, I guess. Okay, so this is the robot model. Okay, and you can do the like path planning here. You can just set the goal position of the gripper. Okay, and let me add that. And you can do the path planning. Just a second. So there is some issue with the simulation, but I think it will be working in the visualization. Let me check. Basically, what is happening is that like we can move the end effector. Okay, and maybe I can just close this and start it again. So Panda move it config. Demo.launch. Okay. Yeah, I think this will be better. So I'm just showing the motion planning. So I'm just moving the robot to here. Then planning it. So you can see the robot is going from that position, the initial position, to the goal position. Okay, so this is the robot motion planning. Okay, and there is a framework called Move It. Okay, so this is actually helping us to do the motion planning in robotic arms. Okay. Okay, guys, I think I have finished with all the stuff, okay, that I have planned. And this was my course called ROS Developer Learning Path. It's actually was a 1-year course. Okay, I just finished. It was a live class, and currently I'm not doing the live class, I have the recorded session. So if anyone interested, let me know. So there are 4 modules. ROS for absolute beginners, mastering ROS, advanced ROS, and becoming a ROS developer. Okay. Yes. So if you have any question, you can ask. So this is my ID. This is a the company website as well, Qbotics Labs. So we are mainly into service. We build software for robots. Okay. Yeah. So any question, guys? I know everyone is hungry. So if you have any question, please let me ask. Any question, guys? Okay, I think that's it. So so we can conclude the session. I hope you will. You get some idea on ROS. Okay, to get started with it. Okay, and there are many other things to learn as well. So let be this workshop be a starting point. Okay, so if you are interested to learn ROS further, I think you can use the ROS website as the primary um, learning point, and also there are many books, not only from mine. There are many ROS based books, so you can also refer that. Okay, and there are many tutorials available. Okay, both video tutorials and blogs. Okay, so you can read that and learn more about ROS. Okay. Okay, then, Tamim, I think we can conclude the session.
Yes, sir. Thank you, sir. Now I invite Hidad Dilip for a vote of thanks.
Hello, am I audible?
Yeah. Yes.
Okay. Good afternoon, everyone. I'm Hidad Dilip, and the duty entitled upon me is to do the vote of thanks. The session on robotics operating system, it was really an informative session, and I'm sure this has helped many of our students to have an insight on robotics as well as robotic operating system. So on behalf of IEDC TKMCE, I would like to extend my gratitude to Mr. Lentin Joseph, CEO of Qbotics Lab, for leading such a wonderful session. And moreover, I would also like to thank all our participants who have actively attended this 2-day event. Thank you.
Thanks, everyone. Bye. So if you have any question, you can ping me or you can connect me in LinkedIn as well. Okay, then. Bye, everyone. Thanks for attending. Bye.
Thank you, sir.
Yeah.
Thanks, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.